Right. So this is the chief reader report for the student responses on the APCSP create performance task. And these are results from last year. And it shows that the number of students scored, so over 160,000 people took the exam and 500 people graded it. Okay, these were the results. Of that, 11% got fives, 24, 31% received threes, 22s, and 16% received ones. So overall, the average was a 2.9 of everyone. Now, we want everyone in this class to get threes or above. That's the goal. Threes or above. No, this is the overall exam score, right? So you get a 5 on the exam. The create task and the multiple choice exam go together to give you your ultimate exam score. It's just sharing here that this is what plays into the create task. The create task is 30% of your grade. Okay. On the last document that we just went through, the scoring guidelines, we read about the 6 rows. So you get 1 point if you did it right. You get 0 if you got it wrong. Look at the means for each. So looking at this, which row is the most commonly missed row? Row 3. Okay, looking back, row 3 was managing the program complexity. So show me that the list manages program complexity, right? Not just show me that you have a list. Show me that, like, if you had variables instead of a list, like why the list would be better, right? So if you create a list with like 2 elements in it and you're trying to explain why it's better to use a list here, doesn't really make much sense. The row that was very highly scored was row 2. And row 2 was the one that shows how the data is actually being stored in the list. But row 3 was showing how. So you basically told me a lot of people on the AP exam, on the create task, do a good job of showing the list, but then explaining how it manages complexity. Look at the big drop from that. They're still talking about lists, but it's almost like a lot of people just are like, hey, look, I use this list, and just copy and paste their response. Explain how it deals with complexity. It says, what were the responses to this question expected to demonstrate? It's designed to give students an opportunity to develop something that solves a problem and allows them to also pursue some sort of creative interest. Some of you guys go through this class and just follow along and do the projects and, are able to get through it. But show me that you can take something you're interested in, or show me that you can solve a real world problem with what you know, right? If you're just really good at spitting everything back, I send something to you and you spit it back to me, right? That doesn't show that you actually understand it. Show you're able to use your knowledge to do something with it, right? If I show you how to make a website, you then go and start your own business and make websites for people, and have made websites for several, I guess, friends, family, and maybe make money off of it. That's like an example of like you taking what you've learned and then applying it in a way that's functional. I share that because a few years ago, there was a basketball player. His name was Eddie, very good basketball player. Back when we were in the A conference for basketball, he ended up taking my class. We had a website design class. He then went and he found 27 people to make websites for at $500 per just to create it. And then from there, managing the websites, it would be an extra, I think he said like it was $150 to $200 a month. But was able to find people. Once he made one website, someone else asked him and said, hey, can you make me a website? Make me a website. And next thing you know, he had all these clients. But it was based off of like learning something in a class. So, with that, like you're given these tools, it's almost like, you're given a toolbox, and if the toolbox just sits there and you never use it or even like want to use that toolbox, that's okay. But the create task demonstrates, show me that you know how to use the tools that are in your toolbox. Students should be able to demonstrate the program running in a short video and explain its purpose, how it functions, and how it handles input and output of information as shown in the video. Programs typically process collections of data to help the user gain insight and make decisions. This task also requires students to demonstrate their understanding of data abstraction using at least one list or to hold data that is critical to fulfilling the program's purpose. Okay, the part that students miss points on, managing the complexity in the program. So what's the most commonly missed in a list? It's how it manages complexity. It's the most common problem with explaining your list. It's how it manages complexity. Said it 3 times. Programs use procedures to break a larger computational task into smaller subtasks to make a program easier to develop and test. I love breaking things down. I love decomposing problems and breaking them down into smaller bite-sized chunks that I can then pass on to other people, or that I can then do in increments and not have to look at this huge task and say, I have no idea how to tackle this. Some of you guys miss school, for example, and then you have a huge list of things to do. And you might look at this huge list of what you need to catch up on, or just a bunch of not turned ins. And you're like, where do I even start? The process of looking at this list of things, scheduling out when you're going to do them, breaking them down, saying I'm going to do half of it here, a piece here, a piece here. I enjoy that. That's called decomposition. And if you're able to break things down to smaller bite-sized chunks, you can then reuse those procedures later. Okay. I'm very procedural. I develop bedtime routines for my kids, morning routines for my kids, routines of what to do when they walk in the house. I have OCD and I walk in the door. And if I don't put things in a certain place, I lose it. The problem with that is, though, when I rush, I get messy. And when I get messy, I lose things. And when I lose things, I get frustrated. When I get frustrated, then it all just spirals. So I recognize that when I walk in the door, I need to take my keys out of my pocket, my phone, my ID, everything. See, my IDs are, I'm like, where is it? All right, it's over there on my desk. But if I don't put it in this bowl right by the front door, I lose it. It'll be gone forever. I'm not good when things aren't super organized and procedures are developed. I'm going to forget things. And that's why I have classroom procedures. They're for you guys, but I strongly argue that these procedures will help you if you follow them. And that's why I developed them. I enjoy procedures. Sometimes procedures can get dull and boring if you're going through it over and over and over again. But with that structure is very much needed to be successful. So we want students to learn how to manage complexity when things get hard, to continue to be resilient. That's one of the best things, one of the best character traits you can learn as someone that is solving problems in this sort of environment via writing code in this case. But are you able to continue to push through when things get hard? Are you resilient? Are you willing to sit down and spend the time to learn something new? If you're learning a foreign language, you don't just learn it. You have to sit down. It's really hard here in the United States, right? Because everyone speaks English. But like in other countries, if you go live in a foreign country, it's a lot easier to learn it there because you have to use it on a regular basis, right? It takes a lot of time. You can't just like skip. Like, I don't know Arabic. If I were to say, hey, I want to learn Arabic, I can't just say like, all right, ready tomorrow. I need to know Arabic. It's not how it works. If I say, hey, in 3 months, I need to be fluent in Arabic. It's not how it works. You have to realize it is a timeline. And for some of you that are just now learning and a little bit behind other students in class, that's fine. Just recognize it takes time. Some people have been doing this for a while. And even people like me who have been doing it for a long time, I make mistakes. I forget things. I confuse things, especially if you're like working with different languages. It's sometimes hard to remember what exactly you were dealing with in one and the other. And if you don't do it on a regular basis, then it becomes even more confusing. Okay. Programs use procedures to break a larger computational task into smaller subtasks, right? As I mentioned, we want to break things down. You should be able to explain how the procedure works in detail. And from that, it says, how well did the responses address the course content related to this question? Some issues. Some students were able to state the purpose of the program by describing a broader problem that is being solved for the user or the creative or artistic interest being explored, whereas other students incorrectly stated the functionality as the purpose, right? Why do you bring a water bottle to class, right? Well, the water bottle holds water. Why did you bring it to class? So that way I can drink water when I'm thirsty. Well, why do you want to drink water when you're thirsty? So I don't get dehydrated. Why would you not want to get dehydrated? Because I want to be healthy, right? What's the why? Why are you doing this? Students don't express the why. They tell me what it is and don't tell me how it works or why it works. Okay. In the case of creating games, some students incorrectly stated the object of the game, how to win, rather than the purpose of the program. Right? Why did you make this program? Well, the way you win is by scoring more goals than the other team. But why would you want to get more goals than the other team? Right? Why did you make this? Okay, so this goes through. I'm not going to read through this entire thing, but this goes through and demonstrates like some FAQs, some common misses. I encourage you to read through it. It's a lot to read through. I'm doing a lot of talking. There's a lot of content to look through. So I'm giving us this whole week to go through it together. Now I'm going to select 25 questions from the things that I talk about here. And it's going to be on a quiz that I'll open up later. Okay, knowing this create task inside and out is very important, right? It describes what high scoring responses did. And this goes hand in hand with that AP exam administration scoring guidelines sheet as well. Check this out. High scoring responses. Looks like Python. Look at that. High scoring responses display lists that are used to manage complexity by storing a variable number of data values that need to be processed using a loop or iterator. So for example, right here, sum is assigned 0 before it starts. For each temperature in the temperatures list, we're going to add it to what the sum is. So if the temperature is 100, it will add it to 0, and then the sum is now 100. At the end, once you've added all the temperatures together, you take the sum, you divide it by how many temperatures, this is Python, how many temperatures were actually in that list, and then you get the average. And then it loops through again, and it says, if the temperature is greater than the average, then print it out. So this is an example of a high scoring one. It gave you a Python example there. So it's good to read through this. You cannot take this, pick it up, and just dump it in your brain. You have to do the work of reading it. And something has to motivate you to sit down and be like, all right, I'm setting a timer, 30 minutes. I'm going to focus on this. 20 minutes. I'm going to read through and just spend time looking through this and taking notes. You're going to forget things. It's too big of a project in terms of all the specifications to just remember everything. At least that's the way I function. I need to write things down. Okay. So you go through, it gives examples of what works, of what doesn't work. And each response, it gives you in detail. It does a good job of helping you and sharing all this with you. They want you to do well. They want you to know what the guidelines are. They want you to know what students did well in the past. Okay. But that is the Chief Reader Report on student responses. Highly recommend reading through that.